same, or it may be similar.
It's online.
That was a good one.
Okay. Starting with projectile motion. Projectile motion, I can do this with a little diagram I like to do. Rifle, and it's above the ground here. Here's the ground. And the rifle is horizontal, and we're gonna shoot a bullet.
That's real, I don't support gun violence.
Well, this is a just pretend gun, okay?
That looks like a,
And we're gonna drop a bullet.
for
also.
real,
We're gonna drop a bullet, we're gonna shoot a bullet.
what kind of gun is that?
It's 22 rifle.
Shouldn't that be like the shells or something though?
Yeah, that's a shell out of that.
And the bullet is gonna go a mile, and then it's gonna hit the ground. This is 1 mile. Here. Okay. Now, the bullet is fired from the gun at the same time you drop the bullet. Which one's gonna hit the ground first?
When you drop the bullet,
Well, yeah, when you
when you drop.
You said what, the bullet's going a mile and the one that dropped, which one goes faster? The bullet we shooting on when we drop it?
when they
The
decide-
The one that drop gonna fall
decide
first.
that-
But isn't that law that they're gonna be the same?
Thank you. Ta-da. Now, one person paying attention, that's right. Horizontal does not affect the vertical. So this bullet hits the ground at exactly the same time as that one does. It's a mile away, but it's only traveled the same distance vertically. And so it hits at the same time. Okay. So projectile motion involves what? Horizontal and vertical motion. And how do they compare? Whoops.
But that's without like wind drag and everything, right?
Even with wind drag,
So
they should still land at the same time. It won't go quite as far, the wind will make it land sooner horizontally. But vertically, you're going such a short distance that the air friction is negligible, vertically. Okay? So horizontal, you got constant speed. And vertical, you got what? Yes? Constant acceleration. And I just ran out of room there. That's an N. You can see that. Constant acceleration vertically, constant speed horizontally. They do not affect each other. They are separate, just like separate motions. When is work done? Well, what's necessary for work to be done? What's the minimum, what's the requirement? What do we have to have for work to be done? Well, what's the formula? Formula is FD equals some theta. So if you have a force going this direction, and you have a displacement going in this direction, and the angle between the two is theta, then this is the formula that describes the work done. Now, if they're in the same direction, what's the cosine theta? Well, cosine 0 degrees is 1. Check that on your calculator if you're not sure. Just type cosine 0, and you'll get 1. So if they're in the same direction, you don't really need the cosine. Now, what if you only have force and you don't have direct distance? No work. So for example, if you have a satellite going around the Earth in a circular orbit, then that satellite has a velocity, so it's moving a distance, and it has gravity. Which is at right angles. Well, what does this formula tell you if you have a right angle?
That there wouldn't be any work done.
Right, cosine of 90 degrees is 0. So if the two are at right angles, then there's no work done. And that's great. That means that it doesn't require any work to keep the satellite in orbit. If there weren't any air up there, it would never come down. There is a little bit of air. You never get above the Earth's atmosphere. If you go between galaxies, then there's some places where you might have 1 hydrogen atom per cubic meter. But that's still some mass. Not much, but you never get to 0